Okay, I'm going to do just the integrals of some of the trickier ones. We did some easier ones in class. I think you're catching on to those. So starting here, our first rule is to let u equal the exponent. If it's not equal to 1, we want to try that. It's worth trying it first. So x to the 1/2, do your substitution, du 1/2 x to the negative 1/2 dx. Solve for dx, 2x to the 1/2 du. Multiply by x to the 1/2, multiply by 2. Go to substitute, rewrite e to the u, x to the 1/2, dx is 2x to the 1/2 du. Stuff cancels out. Nice part is you get it down to e to the u. Integral of e to the u is e to the u. When you put your u back in there, all good. Second one, I could let u equal this negative x, but all that would take is a -1. I don't think that's going to, basically I'm going to rewrite it, and I'm going to have e to the u over 1 plus e to the u. So next thing to try is to let u be the denominator, which means there's going to be maybe a log involved. So we got to try it. Derivative so multiply or divide, however you want to solve that. So you get negative du over, oops, sorry. This is, we're going to multiply by negative e to the x. Because when you multiply those e's, you're going to x to the 0. So negative e to the x du equals dx. Well, let's see if something goes away. So we go back over here, substitute. This is just e to the negative x over u. When we put in dx, we get negative e to the x du. When you multiply these two together, that gives you e to the 0 times -1, or just -1. Integral of 1 over u is natural log of our original value. So again, following your rules, use denominator. Okay, number 109, this is a power. Good substitution rule is to let u equal whatever is being raised to a power, which means we have a chain rule that we are undoing. So u equals 1 minus e to the x du equals negative e to the x dx. Dx equals du over negative e to the x. Substitute e to the x, u to the 1/2 du over negative e to the x. E to the x's cancel out. Taking the integral of negative u to the 1/2 du. So I'm going to integrate, raise by 1. So u to the 3/2 divide by 3/2 is 2/3 u to the 3/2 plus c, and then take and plug that back in for u. So you end up with negative 2/3 1 minus e to the x to the 3/2 plus c. A little tricky. I'm going to just start this one, not finish it, because again, you're starting to see a pattern. Try to let u be the denominator, and then see if when you take the derivative, you get something really close to the numerator. So derivative of negative e to the negative x is e to the negative x times -1 minus, so that's going to be a plus. And you notice, so if you're going to solve for dx, dx is just going to cancel right out. This is going to cancel out there, and you're just going to have 1 over u. It's going to be a natural log. So they start to follow pattern. Let me get to the bottom of the paper here. Sorry, I'm using some scrap paper. This is a little bit trickier. You can let try to let u be 2x. So du would be 2 dx. dx equals du over 2. When I look, that's not going to help me out very much. Not going to substitute very much. But you might also notice that you have a monomial denominator, which is the same as if you had like 7 plus 5 over 3. You can split up into 7 over 3 plus 5 over 3. That's the same thing. So you can split this up into two integrals, 5 over e to the 2x minus e to the x over e to the 2x. And then rewrite and use your shortcut rules. So 5e to the negative 2x. Now e to the x over e to the 2x is 1 over e to the x, which is e to the negative x. These just integrate quickly. I have like 10 seconds left. That's where you can do your u substitution. You can check the answer in the back when you get there.